than closed landfills, which have urgent landfill reclamation needs. This technology consists of pre-stabilization, separation, and solid recovered fuel production. The first step is pre-stabilization, a process which, if necessary, is used to remove explosive gases, including methane, as well as potentially odorous gases such as ammonia and hydrogen sulfide. Inserting injection and extraction well into landfill waste layer, connecting them to pre-stabilization system, and then injecting mixture of air and aerosol less than 5 to 25 micrometer into landfill waste layer through distributor. After that, extracting explosive gas and odor gas generated from this process to treat with biofilter, and then excavating and transporting stabilized landfill waste to separation area. The second step is the separation process, which sorts the landfill waste into soil, combustible materials, incombustible materials, and metal. The landfill waste is removed from the landfill and transported to the separation units, where a backhoe places it into the automatic feed hopper. If a potential odor is detected during the separation, a deodorant is sprayed into the waste material. In the first step, a trommel screen is used to remove and separate the soils present in the landfill waste, which are less than 35 millimeters in diameter. The trommel screen is equipped with customized blades on the inside and brushes on the outside to prevent clogging of the screen by the soils and wastes. The recovered soils of less than 35 millimeters diameter, which contain non-soil materials such as fragments of organic material, vinyl, or plastic, are not allowed to be used for cover soils or construction filling. The trommel screen is combined with a rotating rake, allowing highly accurate and efficient sorting and separation of those smaller fragments, allowing the separated soils to be recycled. After passing through the trommel screen rotating rake, the separated soil is transferred by a conveyor to a storage pile, typically located outside the enclosure. After removal of the under 35 millimeter clean soils by the trommel screen rotating rake, the remaining waste is separated into combustibles and incombustibles in a series of 5 separation stages, which comprises the second phase of the process. Metals included in the combustible fraction are recovered by a magnet and are transferred by a conveyor to a storage pile, which is typically located outside the enclosure. The incombustible fraction is transferred by a conveyor to a storage pile, which is typically located outside the enclosure. The soil and the incombustibles recovered from the sorting system can be recycled and used as fill material, cover soil, construction base, or other uses. The third phase of the process is the production of refuse-derived fuel, RDF, from the remaining combustible materials by a series of shredding, purifying, grinding, and drying steps. The combustibles enter a shredder and are reduced in size to less than 150 millimeters in size. Any incombustibles remaining in the fraction are removed by another separator to enhance the combustible's quality and heat value as RDF. Any metal remaining in the combustibles fraction is removed by a magnet and ground into particles less than 80 millimeters in size by a first stage grinder. Incombustible foreign matters in the ground combustible stream are removed by a vibrating screen. Light combustible material is removed by a tornado vacuum device. Heavy combustible components are resorted by a combustibles precision separator. The combustible materials recovered by the tornado vacuum and the precision separator then enter a second grinder where they are ground to less than 50 millimeters in diameter. The ground combustibles are dried as necessary to meet the standards of RDF by passing through a first stage and second stage dryer, producing fluff type RDF. Finally, the fluff type RDF enters a compactor and baler, producing a compressed cube to facilitate storage and transportation to the refuse to energy